Dear students, the topic of discussion today is molecular compounds. So molecular compounds is, you can find the name molecular compounds, compounds which are made up of molecules. So earlier we talked about ionic compounds. Ionic compounds means there were two parts of ionic compounds, if you remember. One was the positive part, we call positive ions or cations. The other part was negative ions, which were called anions. And then you combine the anions with cations to make a compound. So these compounds, because they had ions in them, that's why we call them ionic compounds. But these compounds are a little bit different now. For the compounds we will discuss right now, these are called molecular compounds because these compounds we cannot find any positive or negative charges. There are no charge separations. Means we don't find any cations, we don't find any anions. But in these all compounds in your course, we will restrict ourselves to binary compounds. Binary compounds mean maximum two elements would be there, different elements. Suppose one is carbon, the other should be oxygen. If it is one is carbon, the other should be hydrogen, or even sulfur, or any non-metals. So let's define the molecular compounds. Before going to the molecular compounds, we should clear our mind about the compounds. What are compounds? Compounds are the combination of two or more than two different elements. The atoms of different elements, they combine together to make compounds. So these are called compounds. And then the molecular compounds, those compounds which have molecules. Now, let's talk about a little bit about the definition of this molecular compound. The compound in which only non-metals elements are present are usually molecular compounds. So means, how would we know this the compound is molecular or not? As we mentioned earlier in our theory classes, that we have in periodic table we have two sides. One is the metal side, the other is non-metal side. The metal side uh, we call metals, the non-metal we call them non-metal, means it is on the right side. The left side is metals. If we have metals combined with, in combination with non-metal, usually we expect that this molecule or this compound will be ionic. But in these molecular compounds, both are non-metals. On the right side, suppose sulfur with oxygen, nitrogen with hydrogen, etc., etc. So we will give you example of water. Let's see. Suppose we have two hydrogen here. They combine with oxygen, one oxygen, and then they make water, which is H2O. If you look at hydrogen, hydrogen is a molecule. It's a non-metal, and oxygen is also non-metal. And oxygen is also non-metal. So non-metal and non-metal, they combine with each other. Now the main thing about the molecular compounds are nomenclature of molecular compounds. Nomenclature means naming of molecular compounds. How to name a molecular compound. Usually we have discussed earlier how to name an ionic compound. Now, because we're talking about molecular compound, the molecular compound naming could be a little bit different than the ionic compound. So we have certain rules to name these molecular compounds. Suppose if you look at the periodic table, it is in front, it's in front of you. So it is here in front of you. You have some of the metals, they are the colored pink color, and some of them they are pink, they are a little bit bluish color. In the middle they are green color. So all these elements which are pink colored, they are metals. Okay, so all elements those are in blue color, like we have carbon, we have nitrogen, oxygen, fluorine, we have P phosphorus, S sulfur, Cl chlorine, and then we have, if you go down, Se selenium, Br bromine, I is iodine, and then all the noble gases, which is group 8 elements: helium, He, neon, Ne, Ar, argon, krypton, xenon. But we are not interested in the noble gases because usually we expect that they don't make compounds. They don't participate in bonding or making compounds. And then one of the non-metal is on the left side on the top. This is hydrogen, H1. So this is the only non-metal you can find here on the left side. So how to name these molecular compounds? We have certain rules for it. Usually, as I mentioned in the previous slide, that molecular compounds, we may have many elements combined together, but in our naming we should only take those examples in which maximum 2 elements are there. So we have certain rules. Let's talk about the rules here. Suppose we will take example of carbon and oxygen, which makes a compound with a formula CO2. Can we write it as O2C? The answer is no. Why? Because the IUPAC rules say that the elements on the right side of the periodic table are to be written first, followed by the left side in the same period. Suppose you already see carbon. Where is carbon? If you can see carbon in the periodic table, it is number 6, carbon. And then the oxygen is number 8, which is on the right side. If you look at the carbon in the non-metal side, it is C, carbon, and then after C there's N, nitrogen, and then there's oxygen. So the IUPAC actually says that if you have molecular compound between two non-metals, you have to look at the position here. If carbon is on the left side and oxygen is on the right side, you must write carbon on the left side and oxygen is on the right side. So you cannot see the opposite. You cannot write the opposite. Suppose if you have a compound between carbon and oxygen, so you should write it CO or CO2, not O2C. These are the IUPAC rule. Why? The reason is very obvious, but I think we don't want to discuss it because the left side elements, they have low electronegativity values. What is electronegativity? We may discuss in some other day. So electronegativity means the electron affinity. They cannot attract electron with high power like this. So, but we don't want to talk about the electronegativity. We talk about the position in the same period. The most important thing is same period. If you look at carbon and oxygen, they are in the same row. If they are in the same row, the left side element should be written on the left side, and then the right side should be on the right side. That's why we write CO2. Now we go for some other examples. Suppose we have prefixes: mono, 1, di, 2, di, 3, tri, 4, tetra, 5, penta, 6, hexa, 7, hepta, 8, octa, 9, nona, and 10, deca. So these are the prefixes actually. What do you mean by prefixes? Sometimes you have more than one atom. Suppose you have carbon with 2 oxygen. Carbon is carbon, oxygen is oxygen, but the number of oxygens are 2. So how would you mention that there are 2 oxygen? Because we have some example in which their carbon is with 1 oxygen only. So how would you differentiate between CO2 and CO? They are 2 different molecules. They are 2 completely different compounds. That's why to differentiate the number, we have to use prefixes before the name of the element. Monoxide, dioxide, trioxide, depends how many numbers are there. If we have 3 oxygen, we can say trioxide. Fe4 oxygen, we can say tetroxide. Fe5 oxygen, we can say pentoxide. If we have 6 oxygen, we say hexaoxide, 7 heptoxide, 8 octoxide, 9 non-oxide, and 10 dicoxide. So we can use these prefixes before to mention, to talk about, or to mention, to mention the number of each element or each nonmetal. The name of SO3 is what? This is our question. Sulfur trioxygen, we have options. Sulfur trioxygen, the first one. The second one is monosulfur trioxygen. The third one is sulfide trioxygen. The fourth one is monosulfur trioxide. The sixth one is monosulfide trioxide or sulfur trioxide. Those are few 1, 2, 3, 4, 5, 6 options we have. So which name is correct? If you look at it, SO3, 1 sulfur, 3 oxygen. So now we have to follow the rules. We have to follow the rules. 3 is oxygen, of course we have to mention it. If it is more than 1, we should mention it. If it's 1, sometime we mention it, sometime we not. So we will talk about it when to mention 1 by mono. And then if there are 2, 3, 4, 5, 6, we have to mention the number. So sulfur and 3 oxygen, we have options now. Is it okay sulfur trioxygen, monosulfur trioxygen, sulfide trioxygen, monosulfur? We have these options. So let's go for the answer. The answer is sulfur trioxide. Why? So we should have some reason for this, because if you look at the writing here, the first element name should be written as its actual name, like sulfur. Sulfur is the actual name. You should write sulfur. If it is only 1 and number, no need to write to add mono as prefix. Means if you have suppose sulfur SO3, no need to write monosulfur trioxide. Monosulfur is wrong. The last element should have name with suffix "ide". Means the first element you should write sulfur, the other should oxygen. Don't write oxygen. Suppose for oxygen, don't write oxygen, trioxygen. You should write trioxide. So these are the rules actually we should have. We should know the rules of it. So sulfur SO3 means sulfur trioxide. Why we use tri? Can I write monosulfur trioxide? No, this is wrong, because if you have 2 elements, the first element number is 1. No need to write mono. No need to write mono. If the other element is 3, suppose you write 3 oxygen, trioxygen, because we have the prefixes. If you look at the right side, 3 means tri. So it is tri, but we should write oxide, not oxygen. Why? Because the second element should always be written with IDE, ide. Oxygen, oxide, carbon, carbide, sulfur, sulfide, nitrogen, nitride, if they are on the right side. Okay, so let's go for the next slide. The name of N2O is, what is N2O? Now, nitrogen oxide, this is the first option. The second option is dinitride oxide. Is it okay? Let's go for the third option, dinitrogen oxide or dinitrogen monoxide, or we have the last one, which is dinitrogen monoxide. Now we have 5 options for this one. What should be the name of N2O? N2. Now look at this. We have 2 elements. One is on the left side, one is on the right side. The left side element, if it is 1, we don't write mono. But if it is more than 1, we must mention the number. Suppose there are 2, nitrogen are 2. So as we mentioned earlier, that the first element should be named exactly what is the name of element. Like N is for nitrogen. But the prefix we use from the table here on the right side, 2, N2. So we can write dinitrogen. We can write dinitrogen, not nitrogen. What about the last element? It is O. But how many O we have? 1. Now, if the second element number is 1, we cannot write dinitrogen oxide because this is 1. We must mention 1 for the second element, not for the first element. So it should be dinitrogen monoxide. Let's see. Dinitrogen monoxide. But if you look at here in the downward, in the last two options, dinitrogen monoxide and dinitrogen monoxide, means you can read it monoxide because there are two O. Whenever you have two O, you have to cross one O of them. It means monoxide. You cannot write monoxide. You say monoxide. That's it. Okay. So means the fourth option is correct. So this is dinitrogen monoxide. Let's see. The answer is dinitrogen monoxide. Why? The reason is the first element name should be written as its actual name, as we know from the previous slide, nitrogen. But the prefix, because nitrogen is not only one, if it is more than one, so we can write try the prefixes we use because there are two. So we will read, you need to write a corresponding prefix, means to it. Suppose there are two, so we use dinitrogen. Two prefixes di. The last element should have name with suffix IDE. As we know, it should be oxide, of course, not oxygen, for oxygen. Now, if the last element is 1 or more than 1, in both cases you should write the number. If it is 1, you should use mono because 1 is mono, the prefix. If it is more than 1, you should write di or tri like this. Okay. Is it correct to write dinitrogen mon? Means there are two O together, the vowels together. Don't write two O or AO if they are together. You should write always one oxygen, means dinitrogen monoxide. Okay, if you look in the slide here. Now we have CO2. What is the name of it? Because we have one carbon with two oxygen. The first carbon is only one. We don't need to write monocarbon. Just write carbon. 2, the other element is oxygen, but because it is on the right side, we should write oxide. But how is the number? 2. So 2 prefix is used, dioxide. So carbon dioxide is the name. The next is now. This is the same, carbon oxygen, but the number is different. CO. So now, as I told you before, that if carbon is 1, no need to write mono. But if oxygen is 1, you must mention it. So the carbon is carbon, one oxygen for the second element, which is on the right side, you must mention the number. It should be carbon monoxide. Okay. Now CCl4, carbon is carbon, Cl4 is chlorine, but we should make it chloride because it is on the right side. But how many chlorides are there? 4. 4 is tetra. So carbon tetrachloride should be the name. Next is CS2, carbon disulfide, because sulfur should be sulfide. The 2 di means 2. So 2 sulfur are there. So carbon disulfide. NO2, nitrogen dioxide. SO2, sulfur dioxide. Use the same rules for all these elements, the molecular compounds. N2O3, now it's different because now the first element number is 2. So we must mention dinitrogen. How many oxygen are there? 3. So we should write dinitrogen trioxide. Dinitrogen trioxide. Because oxygen is 3 and it should be oxide as well, not oxygen. The next one is PCl5. Cl is chlorine, P is phosphorus. The first element you should write phosphorus and chlorine are 5. So pentachloride. Sorry, this is pentoxide. It is wrong. So it is pentachloride. Okay. So the next one is S2Cl2. S2Cl2. Now because sulfur is the first element but the number is 2, we should write disulfur dichloride. Disulfur dichloride. Now exceptions. Exception means some elements they don't follow any rules. Why? Because they are known before even the IUPAC came into existence. They have their names and they are very common. Suppose H2O. Of course it is water. We don't say this is dihydrogen monoxide. If we go for the rules, it is okay. But nobody say H2O is dihydrogen monoxide. Nobody will know it. What is this? So for H2O, the name comes from the beginning of the civilization, human civilization. That's why it is called water. No need to write to follow the IUPAC rules. Here, and another thing is ammonia has been known since, few, a lot of centuries. So this is called ammonia NH3, and one more thing is methane gas, which is CH4. So these three or four, or maybe more than this, some are very common. So they don't follow the rules of IUPAC. So the IUPAC actually accepted their common names. So H2O is water always, NH3 is ammonia, and CH4 is methane gas.